Hello guys, welcome to Start Pro Tutorials. In this session we will be discussing about wind load analysis on this structure up to 5 stories subjected to different load combinations. So let us begin this session. Initially start Pro. Select new project, give it a space, give name units. I should check it up. It's in meters. So units in meters and kilonewtons. Add beam, finish. Now we go to run geometry, run structural wizard. We select frame model, bay frame, and give length as 12 meters, number of bays 3, height as 3 meters, number of bays 1, width as 12 meters, number of bays 3. Apply. You can see this is our structure. We transfer this model to the main Start Pro screen. Okay. Now we go to 3D view and switch off the grid. Initially select general, define rectangle property 0.45 by 0.3. Select the property and assign it to the entire structure. Assign. Now we assign supports, but before that we need to raise this story to 5 stories. So we select the entire structure using beam cursor and select translational repeat. Number of steps are 5 and default spacing is 3. The direction will be in y direction. Select OK. So you can see this is our building, 5-story building. So now we assign support, create support which may be fixed support. Select support, select front view, assign to the bottom nodes. Now we give to loads. So initially select load case details, add. The first load number 1 will be dead load, loading type will be dead. Second will be live load, loading type will be live. Third will be wind load in X positive direction. Fourth will be wind load in X negative direction. Loading type should be wind. We should rectify it to the third one. Wind load in Z positive direction. Wind load in Z negative direction. We select the third load, just edit, select type as wind, change, close. We can check for others. Okay, once we select the loads, now we give the numerical values to the loads. Select dead load, add first self factor, next will be member load, which is -6 in global y direction. Next we go to floor load, which is -4 from 3 to 18. The range in y direction will be 3 to 18 meters. Select add, close. Now we go to live load, select add, give the live load as only floor load, which will be -2 kilonewton per meter square from 3 to 18 meters. Now we assign the self weight to the entire structure. Also, the uniformly distributed load will be assigned to beams parallel to x and z direction. It is because the -6 kilonewton per meter is wall load, which will be acting on beams. The floor load is assigned itself. Now we need to assign the wind load, but before that we need to define the wind load definition. So select wind definitions, select add. Again let the type be 1 and comments be wind 1, add, close. Select type 1 wind 1, add, give the intensity as 1.5 and height as 18 meters. You can select type, calculate, you can change the categories, building category, wind speed, exposure, whatever as per requirements. Add, factor will be 1, add, close. Assign this exposure factor to the entire structure. Sorry, we should assign to the nodes. Once the wind definition part is over, you can assign wind load. Select wind load, x wind load, factor will be 1, y range will be 3 to 18 meters. Add, close. You can see the wind load applied. Now in x negative direction, we select wind load, x wind load, let the factor be -1, 3 to 18 meters, add, close. Now similar for z positive and z negative, we select wind load, select z windward phase, factor will be 1, the range will be 13 to 18 meters. And wind load in z negative direction, factor will be -1 since it is in negative direction, and the range will be 13 to 18 meters. add, close. You can see it. Once the loads are applied, we can go to case definitions, load case details. You can select add. You can define combinations. So our first combination will be 1.5 dead load plus live load. This is just for name purpose. Factor will be defined in default 1.5. You should define the factor here and select the particular loads, dead load and live load, and send it to the other side. Now you should select add. Next combination is 1.5 dead load plus wind load, either X positive or Z positive, whatever. 1.5 dead load plus wind load X positive. Now coming to the next combination, it is 1.5 dead load minus wind load, which will be X negative or Z negative, whatever you require. So 1.5 dead load minus wind load in Z negative direction. So first select 1.5 dead load, send it to the other side. Now give the default factor as minus 1.51 and select the wind load in negative Z direction, send it to the other side, and now you add. Now going to next load combination, which is 1.2 dead load plus live load plus wind load. So we select 1.2 dead load plus live load plus wind load in Z positive direction. The factor will be 1.2. Select dead load, live load and wind load in Z positive direction, send it to the other side, add. And the last combination is dead load plus live load minus wind load. Dead load plus live load minus wind load. This is just for naming purpose. So select the factor as 1.2, select dead load and live load, send it to the other side, select the factor minus 1.2 and select wind load in X negative direction, send it to the other side. So now we have 1.2 dead load, 1.2 live load minus 1.2 wind load in X negative direction, add. Once the load combinations are finished, you can go to design tab, select concrete, select the particular code, which as for me it is IS456. Define few parameters, especially compressive strength of concrete. For M30 concrete is 30,000 and yield strength of steel is 415000 for Fe415 steel. Similarly, secondary reinforcement Also FE415 and select the ratio to maximum 3%. Now select commands, design beam, add, design column, add, take off, add, close. You need to assign parameters to the structure. Secondary reinforcement 2 and ratio to the entire structure. Coming to design beam, you need to select beams parallel to X and Z direction, because parallel to Y direction will be columns. Select beams parallel to Y direction. So once this process is over, you can go to Analyze and Print tab. You can select no print option, give it add, close. Go to Analyze in menu bar, run analysis, save. So it might take some time for it to process. So once the processing is over, you can go to post processing mode. You can view the deflection for the particular load, or else for different type of combinations. You can see you can get even the bending moment, shear force, axial force. You need to roll the wheel of your mouse. You can even obtain the section displacement animation. Press escape. You can even view the reactions by selecting reactions tab. You can even view the graphs which is required in most complicated structures. Coming to reports, you select output, whatever output you require to submit in the report. For example, you need to submit beam end displacement, beam end displacement, beam maximum moments, beam maximum shear forces, beam maximum axial forces, reactions. So once this is over, you select OK. So in this way the reports are obtained. Maximum moments, shear forces, axial forces and reactions. So this is the end of the tutorial. In our next tutorial we will do earthquake analysis. Thank you.